G'day, folks. Hopefully, you can hear me and hear what's going on here. I'm just getting up the chat room questions from our subscribers. Basically, the way this is going to go, folks, I'm going to give you an idea first at what's happening across Northern Australia over the next week. And then it looks like we've got a fair number of subscriber questions here, so I'll get into answering those straight after we give an overview of what's going on. All right, so let's go into screen share mode, and I'll share with you what's going on over the next. Oops, hang on a second. I've got a bit of feedback. Oh dear. Love best made plans. All right, there we go. That's better. I don't need to hear myself. Okay. All right, let's move into screen share mode here, and we'll get. So what we're doing is we're going to give you an overview here of our weather center and have a look at what's going on at the moment across the. Okay. Screen 2, let's share that. Alrighty. So folks, what we're going to do, we're going to have a look at an overlay of Australia at the moment, find out what's going on across the nation, and then we're going to go into specifics about what's happening post the current setup. Okay, so we've got a low pressure system at the moment. It's located, I'll just make this into a 3-hour loop on our weather center, and there we go. Let that load up. Perfect. Alrighty, so what we've got here at the moment is a low pressure center that's located to the northwest of Tennant Creek. We've got another little low off the coast here of about Bowen to Townsville. That little low is primarily an upper level based system. Now that system will make landfall in inverted commas tomorrow across the northeast Queensland coastline. It'll enhance some shower activity, no doubt about that. And the expectation then is that this surge of moisture here will be brought in by that upper low, and central Queensland will be the major beneficiary of that from about early next week. Across here, this is an interesting setup across the Northern Territory, which we'll talk about very shortly, where two lows may form along a monsoonal trough or along a shear line, and one of those lows will become dominant. At this stage, it looks as though this low to the northwest of Tennant Creek will remain the dominant feature, track in a northerly direction, then begin tracking west across the northwestern parts of the territory, and then start shifting towards the southwest. Whether that shifts on or off the coast is difficult to say at the moment. If it gets off the coast of WA, expect it to become a tropical cyclone. If it doesn't get off the coast of WA, then we'll probably see a deep monsoonal type low pressure system. So that's the expectation here at the moment, folks, with what's going on currently. Let's take a look firstly at this little low here near Townsville and Bowen. And to do that, we'll just go into Queensland. Actually, no, we'll go into Bowen as a overlay. There it is, Bowen. We'll go to the 512 imagery. We'll just take a look at what's going on there. So you've got this little very, very weak area of rotation. It's pretty elongated as well. So that's the rotation at the surface. If we move into the upper levels of the atmosphere and we put in a bit of a model, have a look at some of the model data here, and we'll look at the European model, and we'll look at the probably the 500 hectopascals. Yeah, you can see here on the Euro model, there's a bit of a weak circulation just in there. That's the upper level low, and we'll probably be actually able to see that better on the Access R chart. And if we take a look here at the wind shear at about 300 hectopascals, we'll be able to see that nice and clearly. The Access R chart has it a little bit further to the north than what is probably being currently experienced. But in general, you can certainly see it's an upper level low. So this is, we're looking at about 7 to 8 kilometres above the atmosphere here, and it's located probably a little bit south of that, around Townsville to Bowen. The expectation is that once this low hits the coast, well, once the upper level section of this low hits the coast, we'll probably see a bit more stream shower activity coming onto the coastline, and possibly some depth with that as well. If we take a look at the GFS and we take a look at the storm probability diagrams for the region as that system hits, you can see that we do see the opportunity for storms through Saturday across the area, particularly along the ranges. And the GFS gets a little bit crazy when it starts looking at severe potential. I don't think the severe potential is going to be that high, but you can certainly see an increase in showers and storms across this region of Queensland tomorrow afternoon because of that upper level system. The other thing that this upper level system is actually creating is a situation where if we just get out of here and go into Queensland and take a look at what this system is doing for the monsoon, we'll just get rid of the models and we'll just go into, there we go, perfect. So you can see this is what we call water vapor imagery, and water vapor imagery primarily looks at the upper levels of the atmosphere. We've got a nice upper level circulation here around that Townsville Bowen area, as I mentioned. Now, what that's doing, though, on the western edge here, notice how it's pulling in this really dry air up into the far northern parts of Queensland, into the northern peninsula. It's actually holding the monsoon off from actually coming down, at least the mid-level section of it, from coming down in towards northern Queensland. So it's really drying the place out at the moment, and we're really struggling to see some strong convection developing across the eastern coastline. Now, once this system does track westwards, we're expecting to see this moisture flooding in to the Queensland coastline. However, primarily it's going to start flooding into the central coast and with Sunday's region. Let's take a look here at the projection of rainfall, and I'm just going to take you out of this screen share. You're going to see a black screen for now while I just get the European rainfall chart up. Hang on a second, I'll be back with you in a sec. Alrighty, welcome back. So here we're looking at the European model, and we're looking at the European model based on, and thanks to Windy TV, which is a great little resource here online. Now, the expectation here is that as we go to Monday, we're going to see a deep trough system located just off the North Queensland coast. Now, you can see heaps and heaps of rain occurring on the eastern edge of that. Now, as that at the bottom of the southern end of that trough system, we could see a little circulation spin up off the coast between Townsville and Mackay. That circulation is expected to track southwards, and at this stage, it's a little bit hit and miss depending on the model guidance that you're using as to whether or not it actually makes it to the coast. Now, the big thing to note from this isn't so much the circulation itself. While that's pretty cool to see a little low right on the coast, what is even cooler is this deep, moist feed. Now, have a look. Let's zoom right out and let's have a look at exactly where this wind is coming from. Notice how this air is coming from the deep tropics. It's coming in from the north and the northeast, and we've got a ridge located just here to the north of New Zealand. Now, that's directing a very moist easterly to northeasterly flow into the central parts of Queensland. So you can see here, right in there, we're seeing this greatest amount of forcing at the surface, and we're probably going to see the highest amount of rain on that coastline. That all starts to kick off on Monday. It really starts to intensify on Tuesday, but where this little low lies is going to be crucial as to who gets the strongest rainfall, and this will vary depending on the computer models as we go through the week. So you can see another thing that comes into play here is this big southerly change that pushes up through the southeast corner of Queensland, and that creates some really big rainfall. Once that southerly starts to converge with this easterly and this really deep northeasterly flow, bang, everything starts to happen. And at this stage, models are beelining around that Yeppoon area to see some pretty big falls and quite likely to see some maybe flooding. If we can get this southeasterly moving through and merging or converging, I should say, with this northeasterly, that's when we'll see some really big stuff happening in this area. But we still need these little lows to form up. Otherwise, it's just a simple trough system. So we definitely need some sort of circulation in play here to really enhance that coming together or that convergent flow. As I say, expected to start on Monday. You might start to see showers on Sunday, but you'll start to see something more significant on Monday, and then expected to ramp up on Tuesday, Wednesday, and then from then on, I don't really want to go past that unless our subscribers want me to, and then we'll talk about that in a bit more detail. But you can certainly see here at the what are we looking there? 800 hectopascal level, so above the surface now. We've got really nice forcing occurring around that rocky Yeppoon, down as far as Bundy area. Once we get further south than that, it's dry, it's a stable atmosphere, but once we get north where these winds start to meet, and particularly where they meet at their strongest, that's where we see the strongest rainfall potential. Now, further north around Queensland at the time, definitely in a monsoonal northwesterly flow throughout the state here. So showers, storms developing pretty well everywhere. It's just a matter of hit and miss type luck. Further north in the Torres Strait, of course, you're going to see this nice little northwesterly flow continuing to create some good stuff for you. Now, over to here. This is quite interesting, what happens out here in the Northern Territory. So at the moment, we've got this low, as I said to you, just to the west or northwest of Tennant Creek. Now, that system is going to be very interesting how it all interacts with the monsoon trough. Now, at this stage, the European model is deciding that it's going to make this the dominant circulation. If you just notice, though, I don't have my little drawing tools here to show you, which I did in the subscriber updates. But if you notice that there's a secondary circulation just in through here, or a little area of enhanced vorticity just in there. Now, this is where computer models are getting confused. Some of them develop this little area of enhanced rotation just there as the dominant low. The European keeps this as our dominant low. And so if this becomes our dominant low or remains our dominant low, then that system is expected to drift towards the north or northwest, and then eventually is likely by early next week to be lying very close to the coastline, more than likely south of Darwin, creating this really nice little strong flow of westerlies onto the Northern Territory coastline. Now, the expectation is that this, if we just take a look at the steering mechanisms here, this steering from the south is going to be stronger than the steering from the north, and so the net directional flow of this system should be to the west. However, if the Southern Gulf system decides to become the dominant one, the steering will be slightly different to this. So you can see the ridging here nowhere near as strong as the ridging is through the western half of the Northern Territory. So we've got a directional flow here of this system towards the west or southwest. So, folks, it looks a very interesting setup. And of course, once that system does head offshore, the expectation is, if the system heads offshore, I should say, the expectation is it'll develop into a tropical cyclone, and there's a reasonable chance that it'll develop into a fairly strong tropical cyclone. The other thing that the computer models do disagree on, but are starting to come on board with, is this little low off central Queensland or near central Queensland begins to show signs of some intensification towards the back end of next week, and that's on the proviso, of course, that it's still there at that time. So there are some interesting signs there. But if this was to develop into a tropical cyclone towards the back end of next week, and we take a look at the upper level environmental flow here, we can see it's under the influence of fairly strong northwesterly winds that'll drag it away from the Queensland coast quick smart. So the best chance we've got on the Queensland coast of a sustained enhanced rainfall is if we can keep the system nice and weak and keep it close to the coast. We'll see heaps and heaps of rainfall across this part of the coastline. So yeah, it's very interesting stuff, folks. And if we just take a look here at the accumulated rainfall totals, bearing in mind, of course, that the accumulated rainfall totals over 10 days are going to be quite riddled with errors, but let's just have an idea of what's going to happen here, and we'll just change this to 10 days and give you a quick look. All right, so you can see some really big falls developing here on the coastline of central Queensland. I wouldn't pay too much attention to the 550s and 600s, but just be aware that there is the potential there for 200 pluses on that coastline, dependent, of course, on exactly where those little circulations form on that trough line. You can see this little unfortunate little lull in activity here across the Burdekin coastline. Unfortunately, they don't look like they're going to receive all that much. Once we get into around the Townsville area, they start to look a little bit more interesting, with around that 70 to 150 millimetres in that zone. And up around Cairns looks pretty interesting as well, 100 to 200 sort of areas. Up here on the Western Peninsula, of course, we're looking at lots and lots of rain still on that northwesterly flow. Out here in the Northern Territory, it's difficult to say because it really does depend on which of these circulations becomes dominant. The European, remember, develops this one, and so we see some fairly strong rainfall totals anywhere south of Darwin. We see some really high rainfall totals, and especially in the Victoria River District here around that 200 to 300 millimetre mark. And then obviously it would depend on who gets the rain as to where that tropical low or tropical cyclone ends up tracking. Does it track inland or does it track off the coast? And that's the million-dollar question we're not sure of. So really a lot of indecision here over the next 24 to 48 hours on which one of these systems will take hold, whether it'll be the western one or whether it'll be the eastern one. And computer models do struggle with that. However, once they do lock on to one of these systems as the dominant circulation, we'll see a lot more agreement on computer model guidance from then on, I think. So once we get past this little initial difficult phase in the next 24 to 48 hours, by Sunday night, we'll have a very good idea at what's going to happen up here through this region. Alrighty, so that's it in a nutshell, folks. That's what's happening over the next week. Now, I'm going to take some subscriber questions. So whatever questions our subscribers have given to me in the chat room, I'll now start to approach. So you're going to go back to a black screen for a second, and then we're going to come back to screen share once I've got that up. All right, first question. Someone is an exploration geologist in Blackwater, meant to have his rig back to work soon. Keenly watching now how much rain Blackwater's in central Queensland, will get from this system, in particular the Yarrabee Airport, which shows up on Windy TV. What's going to control how much rain we get inland of Rocky? Which part of the system will I need to be watching? Great questions. All right, so let's move into, once again, we'll use Windy TV for this because I really like the graphical representation here and the dynamic representation that we can get. All right, so let's share Windy TV again. Let's move into Blackwater, and this is probably the easiest way to do it. There we go. Blackwater, okay, maybe not. All right, so we'll go in. Let's go in. All right, so Gracemere, Mount Morgan. Well, I'm pretty sure there it is. Okay, so at this stage, Blackwater expecting to just get into the triple figures, but that can vary. Remember, we're only looking at one computer model here. If we take a look at the Oz Cyclone Chasers Weather Centre and look at the GFS model, and we'll go to Rocky and have a look at the GFS solution for Rocky. Rockhampton, there we go, 256K. And there's Blackwater, and let's take a look at the model overlays, and we're going to check out the 7-day accumulated precipitation totals. Yeah, so we've got fairly good agreement here, both on the OCC Weather Centre GFS scenario of about 50 to 100 millimetres across Blackwater. And we've also got good agreement from Windy TV here of about 100 millimetres based on the Euro modelling. And if we take a look at the Access G model here on the Weather Centre, and just to make sure that we've got reasonable agreement there as well. And it's always good when the computer models do back us up and do show the same sorts of things. So we'll just have a quick look at their precip values for this region. Hide that. All right, so we've got, look, we've got a situation here where most of the heaviest rain, now there is a period there of some moderate to heavy falls developing around Blackwater on Monday afternoon, Monday morning into Monday afternoon. As I say, the strongest rainfall potential on the coast is certainly on Tuesday, and some of that will extend inland, but probably Blackwater is a little too far west of where some of this strongest stuff's going to happen. So the forcing is greatest here near the coast. Once we move inland, there's still that forcing effect, but it's probably not as strong, and certainly the moisture content of the atmosphere won't be as high back here. So even though we might get the same amount of forcing, we may not get the actual moisture content of the air being so saturated back in through here. So expecting showers, storms, general possible rain periods extending inland, but the expectation is that the heaviest falls will remain fairly coastal. Okay, I hope that answers your question. So Monday, as I say, is probably the start of that for your region. and then that'll continue through into Tuesday and likely to continue through into Wednesday. If we just take a look at Windy TV, and just to get some clarification on that, and just to make sure that we're on the same page, and we'll start on Monday here. And yeah, so you can see Monday morning we tend to see some stuff happening around Blackwater there. And if we take a look here we've got these nice little northeasterlies, and they start to shift east to southeasterly through this area as we go through the day. On Monday, you can see nothing too significant until probably Monday afternoon. And Monday afternoon, we get storms popping up all over the place. Lots of convective cells developing through Middlemount at that particular, through Blackwater at that particular time. But you can see here where this heaviest rainfall is, can't you? It's right near the coast there. Wherever these little tiny circulations will form will be where that heaviest rain will be. So folks, that's how it works. And as I said, Blackwater is likely to be a little bit too far to the west to benefit too greatly from this. All right, so that's our first question. Let's move on to our next question. We've got a question here. What's happening with the monsoon? I think I've answered that, so I won't answer that one again. If there's any hope, yep, no worries. How is everyone going? Just wanted to know if there's a chance that Bundaberg might flood in 2017. Hope all goes well with the live feed tonight. Okay, so let's take a look at Bundaberg in detail here. All right, so this is where I'm getting our questions, by the way. This is our OCC subscriber chat for our subscribers on the OCC embedded chat room. Once they log in, they can get in there and they can ask questions. And what I'm doing at the moment is just going through their questions. So let's go into Bundaberg. All right, let's start with the Access R model. The Access R model actually hasn't been updated, so once again, we're going to have to use Windy TV for this one too, unfortunately. The Access R model from the Bureau is taking ages to update today, so I'm assuming there's a Bureau of Meteorology issue. All right, so taking a look at Bundy. All right, so nothing much is happening here Sunday, just some isolated convection. And I'm just having a quick look. I'm sure they said Bundaberg. Yeah, so Bundaberg. So you can see here finally a bit of the northeasterly coming through on Monday morning. And so same sort of time frame. Monday morning, everything seems to want to kick off. And then as we go into Monday afternoon, some heavy showers, heavy storms developing through that region. And then into Monday night, we see that some of that stuff will make it into Bundy. By Tuesday morning, we start to see more of this forcing occurring around that coastline. So you can see Bundy's probably on the southern edge of that forcing. Now we've got this southerly, remember, that's going to be coming up the coast eventually, but it's not there yet. But even that tiny little convergence zone right in there is creating some pretty heavy stuff for Bundaberg. The actual low pressure center somewhere between Mackay and St. Lawrence at that point in time, but you can see lots of convergence occurring here around Bundaberg as well on Tuesday, overnight Monday into Tuesday. The expectation here for Bundaberg is that it'll be on the southern edge of the heaviest activity, but it does vary depending on model to model as to what you'll see on Bundy. This stage, you do happen to be on the southern edge of most of this. Now, bearing in mind through the week, though, the expectation also is that the possibility of these little lows just drifting a little further south, and you can see some of this heavier stuff now right on St. Lawrence, and you can see Bundy still on the southern edge of that. But just be careful, because Bundy could end up making its way, or the rainfall could end up making its way down to Bundy as the week progresses, as we get into the latter parts of next week. It really depends on how strong the ridging that comes up the coast is going to be, and also then how far south this stuff here will move. So folks, at this stage there's no flooding expected in Bundy, but certainly it would be on alert for some heavy rainfall, particularly Monday night into Tuesday, and that's as far as I would probably go with the modelling at this stage. Any later than that, and we're starting to draw some straws and look at tea leaves. So based on the complexity of the pattern right now. All right, let's move on to our next subscriber question. How much notice should we take of the bomb rainfall map for Gladstone? Seems light on. All right, well, let's have a look at Gladstone's rain map on the Bureau of Meteorology. Okay, so we go to BOM. For those of you that don't know how to get it, bom.gov.au, you go to Queensland, and you go to all forecasts, forecast rainfall, and you find your state, Queensland, and you find your district, and it's Gladstone. Gladstone, is that Capricornia? There we go. All right, there we go, Southern Capricornia. So they're talking about the bomb rain maps here being light on in rainfall, and you can certainly see that even out to, what's this day? Sunday night, still no good. On Monday, we definitely see some heavier falls developing. And then on Tuesday, we continue to see some heavier falls. Look, 25 to 50 is nothing to sneeze at, and nothing to laugh about. It's still a situation where we've got some reasonable rainfall. Now, remember, the Bureau of Meteorology's rain maps are made from a number of different computer models that are put together and mashed together. And depending, of course, on where these computer models are picking up these strongest rainfall potential will depend on which areas are getting the heaviest rain. So you can see here, oddly enough, that this area inland of Rocky is actually expecting the heaviest rains. Probably unlikely. You're probably going to see the strongest area of rainfall on or very, very close to the coast, not well inland. So the expectation here is that probably these maps are underestimating the rainfall, and that could form from this particular system. So yes, I'd pay attention to them as a general guide, no doubt about it. But as things get closer, I would start paying attention to more the Access R computer model on your weather center. So this model here will get the rainfall a lot more correct than the Bureau of Meteorology's rain maps over the short term, and or use your Windy TV overlay and have a look at Bundy once we get into that 24 to 48 hour time frame. So you'll have a much better idea about Gladstone, Bundy, this entire region. As you can see on the European model here, Gladstone is definitely in the thick of things through this particular rain event. So certainly looking at some reasonable falls. Now these are 10 millimeters over 3 hours, but they happen over and over again. You can see you're not far off this little section here of getting 30 millimeters over 3 hours. So yes, at this stage, 25 to 50, closer to 50, I would say, on those particular days. But be aware that there will be heavy falls, and at this stage, they're likely to be just north of you. But they may shift southwards with further model runs. So keep an eye on your Access R computer model. All right, let's have a look at our next question here. I live at Daly River, Northern Territory. Just wondering what your opinion is about the movement of the low north of Tennant Creek. All right, so north of Tennant Creek, so let's go into Tennant Creek in the Northern Territory. Good on you, Nitso. Yes, we know it's Northern Territory. We want to go to the Tennant Creek overlay. There we go. Perfect. All right, let's get rid of the models and let's take a look at the visible 500 meter imagery. And we'll just increase that to 512, get a better overview of what's going on, and let that load up. Takes a little bit of time to load up. Got some very nice convection, don't we? Lots of really nice convective thunderstorms developing. Let's have a quick look at lightning here, powered by Metro Weather, and you can see a fair amount of lightning in that stuff as well. So very good cloud top, very high cloud tops. The problem is, and the difficulty here is that we don't really have a strong circulation center. There's a circulation somewhere in here. But it's not really a strong center, and this is what models are really finding difficult. Is yes, they know there's going to be a lot of activity. Now you can see some broad turning in this area, no doubt about it, but you can't find a full-on tiny nice little circulation in this lot of jumbly mess of convection. So this makes the computer models difficult, and this is why we see such variation in what's going on. So we know that there's broad turning here. There's no doubt about that. Where is the center of that turning? Who knows? At this stage, it appears to be this broad area just in through here. But the computer models here are struggling because this isn't a strong circulation center. So let's assume, because if the Gulf of Carpentaria system develops and this one dies out, then Daly River will get not much. Is it Daly River or Daly Waters? Yeah, Daly River will get not much. However, if this particular western circulation actually starts to solidify, Daly River could be in for a lot of rainfall. So let's look at the two different scenarios here. So this is, we'll go to the European scenario and we'll check out what would happen to Daly River in this scenario. Eventually, I'm hoping that it does pop up here. Pine Creek. No, it's too fast. It's too far north. Actually, let's do it the old-fashioned way. Okay, and let's move into here. All right, so there's our Daly River. Is that the township though? Oh, goodness me. All right, let's go to the Oz Cyclone Chasers Weather Centre and let's have a look here at Port Keats, 256k. And there it is. No. All right, so let's take a look here at the first model, which is the GFS that we're going to look at and have a look for get rid of radar, get rid of satellite, and just having a look at the GFS for 7-day accumulation. So at this stage, according to the GFS model, you're going to be too far east of the monsoonal surges that'll be hitting the western coast of the territory, and you're going to be too far west of the tropical low, which the GFS model develops much further to the east and pushes northwards. So according to the GFS, you're probably looking at 50 to 100 millimeters. Now, the problem, of course, at Daly River, as you all know if you're locals, is that what happens between you and Catherine is very important when it comes to the Daly River, because that's the catchment. So rainfall that falls in this area will certainly flow downstream and certainly will increase the river level heights. So just being aware that this area will receive probably upwards of 100 to 150 millimeters over the next 7 days, possibly even more than that if this low decides to get going while it's still inland. You could be looking at something a bit more significant because of the upstream rainfall totals. So while Daly River in this scenario isn't getting too much, you certainly are getting enough upstream to cause some problems further downstream over the top of your township. Looking at Windy TV here, and if we take a look where the rain falls, and once again we'll take a look at the accumulation of rainfall. Wrong one. Accumulated rainfall totals, and we'll take a look at the next 10 days for this region. So you can see at least 100 to 150 millimeters in both scenarios upstream, but the difference in the Euro is that because it develops the low further to the west and tracks it up here into the Joseph Bonaparte Gulf, you're probably looking at some significant 150 sort of millimeter falls right over the township as well. With as soon as you get further west towards Port or southwest towards Port Keats and Wadair, you're probably looking closer to 300 millimeters based on the movement of that particular system. So certainly Daly River is in a problematic situation here, not only because of the rainfall that they're going to receive, but the rainfall that could happen further upstream. And as you know, the river levels at the moment around the township are rising a fair amount with every hour, and probably wouldn't expect that to decrease anytime soon. I would only expect that to increase from here on while these lows are in operation. So sorry about a little bit of bad news there for you. All right, this brings back the memories, Nitso. Thank you. Back when we had to call the bomb on the landline to get the latest updates. Just amazes me that all the models are so disparate. Even at 24 to 48 to 72 hours ahead, there is usually so much disagreement. I live in Darwin and have just watched the Future Aussie Cyclones update, and the low over Tennant Creek could go either way in 24 hours' time. Just goes to show what an inexact science meteorology is, I suppose. I think it's not so much an inexact science. I think there's so much chaos that's going on in the atmosphere. It's too difficult for computer models to. We don't have the power in our in the computations that we use to cover all bases, and so that's why we use an ensemble approach. So if we use an ensemble approach, what we do is we run a number of different computer models. There's over 100 run at every 12-hour interval, and basically they use a generalized mean or average from those computer models to work out what could happen. I know that's certainly what we do with tropical cyclones, although we do weight some models a little higher than others. But you know, you're right. It's not so much an inexact science, compute the science as yet in the computer models. We don't have that power to do that yet. So the atmosphere, as I say, very chaotic environment. fluid dynamics isn't as easy to forecast when you're dealing in so many in both the vertical and the horizontal dimension, with slight little perturbations throughout the atmosphere can really make a big difference. What happened to the low that was in the Coral Sea? It appears to have disappeared. No, I did show you that at the start of the broadcast. It is still there, and it's just off the coast of Bowen. But as I say, there's not much weather associated to it. It'll hit the coast tomorrow, and we'll see some shower activity on the Queensland, northeast Queensland coast. I'll just give you another look at that for those of you that might have forgotten. And once again, I really don't understand why the BOM haven't updated their Access R model here. It's really annoying. So we'll use the 512 imagery, and we'll have a look here at what happens with precipitation values tomorrow as that system hits. So don't worry about that. That's today. So let's take a look from tomorrow morning. So you can see here the low hits around Bowen, and that creates some shower activity further to the south around the Mackay area through tomorrow. Now tomorrow afternoon, the good part of that is tomorrow afternoon the low's going to allow some more moist air to come into the central coast and the Herbert Lower Burdekin region, which will enhance some showers and possibly even a thunderstorm or two in the area. Now remember, it's an upper level low, so it's actually got some really cold upper level environment. So don't be surprised if we see the odd rogue thunderstorm in the area. And if we just take a look at something called the K index to have a look at whether or not the atmosphere is very supportive for storms, and it is. Tomorrow we can see the atmosphere quite supportive of thunderstorm activity tomorrow across this inland parts of the Herbert Lower Burdekin. And if we take a look though at the steering winds, you can see that the steering winds will make sure that the storms stay inland. They won't actually make it onto the coast. So the best chance the coast has is getting a shower on that southeasterly flow because the upper level winds will keep the storms away anywhere south of about Ingham, or well, pretty well anywhere, because the winds are so light. Even though they're favourable up here, they're still coming only at 5 knots, so it's rubbish. You won't get storms moving very far at all across northeastern Queensland tomorrow. All right, so that answers that question. Does this sudden burst of monsoon coincide with a strong typhoon that hit the Philippines, the northwest edge enhancing the northeast flow through the Philippines as a track west to the model interpretation of the surge caused by this? Absolutely, yeah, absolutely. So we had a massive tropical cyclone, Category 5, hit the Philippines about 6 days ago now. And that system, once it hit the Philippines, quickly weakened out. But what it did was it actually created a big pressure gradient squeeze between the tropical cyclone and the high pressure ridge that was building through Japan. And that basically created this situation where we had winds coming across the equator that were being very much enhanced by that system. So if we take a look at how the monsoon works, you can see here we've got a nice little upper or mid-level ridge. Actually, we'll just look at the lower levels of the atmosphere just to make things easier. All right. There we go. Nice. Okay, so we've got a nice little high here over Japan. Now, a few days ago, we had a big tropical cyclone that whacked into the Philippines, and this created a massive pressure gradient squeeze in between these two systems, which resulted in a burst of northwesterlies coming through the South China Sea. Now, for those of you wondering what the hell I'm ranting about, it's really, really important. What happens up here around Japan and eastern China, very, very important, because it basically dictates how much of this northeasterly air comes across the equator, changes direction, becomes our northwesterly monsoon. So a tropical cyclone in this area this time of year can have two effects. One effect is that it blocks off, if it's a really large system, it blocks off this entire northeasterly flow. And so our monsoon dies, and dies very quickly, and we go into a really dry period for Australia. The other effect it has is if it's a fairly small system, but fairly strong, as this tropical cyclone was that hit the Philippines, very strong system, but pretty small. What it does is it enhances, particularly on its northwestern edge, it enhances this northeasterly flow. We actually get a stronger northeasterly flow. It doesn't quite wrap around that circulation, and it pushes across the equator with a lot of gusto, and we get a nice big northwesterly coming through. And this northwesterly is certainly partially a result of that cyclone finally dying, and that pressure gradient now the pressure gradient that was in operation at the time, resulting in that burst of northeasterlies. And now that we've created the system, it's now a nice little feedback loop where we're getting these northeasterlies coming through. There's a nice high in here, and so the monsoon won't be dying anytime soon. Let me guarantee you that. So it'll be sticking around for at least the next week, folks. Good question. Great question, actually. Well done. Well done to our subscriber there. What happened to the low? Yeah, no, we've talked about that. No answers to our questions are appearing. Is this chat room working? I'm getting itchy feet. No, I'm not answering your questions in the chat room, guys. I'm answering them on the video. I think it's washing out near Bowen, looking at the visible. Yes, that's right. It is. I can see the Daly River rising from my kitchen. Yeah, I can imagine. Thanks for that. How do the upper high pressure systems develop above tropical cyclones? Do the upper highs develop when a tropical low intensifies? Ooh, that's a really good question. Now, upper level highs are probably the hardest thing for computer models to forecast. And what ends up happening as we see storms develop, they need an exhaust system. An upper level high is an area of upper level divergence. It's an area where the upper level winds expand away from the tropical cyclone, and we end up seeing a outflow channel developing through that, especially if there's an upper level high and a trough in behind it. Whether or not a tropical cyclone creates an upper level high, there's jury's out. It can certainly, if we were already seeing a fairly weakish type wind pattern in the upper levels of the atmosphere, then yes, it can help to create them. But if we're seeing a convergent pattern in the upper levels of the atmosphere, then no, it doesn't do that. In fact, the convergence in the upper levels of the atmosphere will basically kill off the tropical cyclone because it will not allow the convection to grow to a height that supports tropical cyclone continuation. So we don't want upper level convergence. We want upper level highs. There are a lot of different wind speeds and directions you can see at different hectopascals. What has the most impact on weather? Oh, that's a too difficult a question to answer. All right, so what we look for at the surface. So what we're looking for, folks, at the surface. So the surface and the lower levels of the atmosphere really do dictate what happens with regards to weather. But if they're not supported by what's happening in the upper levels of the atmosphere, so let me just give you an example here. All right, so, and we're going to go get out of Townsville because nothing's happening in Townsville, rubbish. Rockhampton, and there should be some stuff happening there into the future. Let's have a look. Actually, we won't use this model. We'll use the GFS model. All right, there we go. Perfect. All right. So looking at the GFS model, actually, we'll go a little bit further south and go down to Bundy and have a look at Bundy. Do we have Bundy on the thing? No, we'll have Gympie. We'll go to Gympie. There we go. Should be able to see it there nicely. Okay, so we've got the lower levels of the atmosphere. Now, we need some squeezing. I love to use the word squeeze because people understand that a little bit better than convergence. So when we get this squeezing effect of the wind in the lower levels of the atmosphere, we get, well, basically air that squeezes has to go up. So we need that squeezing effect at the lower levels. All right, if we can get that squeezing effect, then we want to make sure that there's enough moisture in that air, because if we're squeezing dry air, well, we're not going to make too much weather out of it. So the first thing we're looking at is, do we have a bit of a squeezing at the surface? And yes, we got some squeezing, some really good stuff happening down here. All right, so then we take a look at, well, what is the moisture content at in the lower levels of the atmosphere? And to do that, we basically use an overall view, so 512 Ks, find out where the origin of this air is coming from. If it's coming from the tropics, the chances are it's going to be nice and moist at the surface. Not so much in the upper levels, but certainly at the surface, it's going to be very nice, moist air. Okay, if it's coming from the Southern Ocean or the Tasman Sea, chances are it's probably not going to be as moist. So that's why we're probably seeing the heaviest rain up here, where these northeasterlies are squeezing with the easterlies, than we are down here, where there's still a bit of squeezing going on, but it's coming in from the southeast. So these winds will not carry as much moisture as these winds will. So if you get squeezing in the lower levels of the atmosphere with heaps of moisture, you get heaps and heaps of clouds and rain. All right, so that's what we're looking for. Now, what we want to see also in the upper levels of the atmosphere, hopefully, is a little bit of cooler air. So we're not so much looking for the winds here. We're looking for cooler air. So let's take a look at the temperature at 500 hectopascals. And so this is probably the one thing in this setup in central Queensland that's just lacking a little bit. See, ordinarily to get a really heavy rainfall situation, we want to see that squeezing at the surface, and then we want to see nice, cool upper level air. And when we can get that happening together, that's when we start to see some really strong rainfall potential. That's when we're talking about those really big 1 in 50 year, 1 in 30 year type flood situations, you know, where you get 3, 4, 500 millimeters in a day. So until we see that, that general squeezing effect that you see at the lower levels of the atmosphere will only give you that sort of 50 to 150 millimeters in a day. If you can get some upper level support, you certainly can increase that. When you talk tropical cyclones, though, which might have been your question, we tend to look at these levels, the 500, the 300, and for a weak system, the 700 hectopascal level. So what we're looking for here is which direction the winds are coming from. So they don't dictate our weather so much as they do where cyclones go. So primarily what dictates our weather on the surface are the winds in the lower levels of the atmosphere. And what dictates the movement of a tropical cyclone are the winds at 700, 500, and 300 hectopascal. Tropical cyclones are too strong to be dictated by what's happening down here at the surface. And they're probably slightly too weak unless they're a really strong system. To be dictated by what's happening way up at 200 hectopascals. And so this little thing here, tropical cyclone shear magnitude, shows you how much wind shear operates between the different levels of the atmosphere all the way up to 300 hectopascals. So obviously with a tropical cyclone, you guys should know this as subscribers, we need 20 knots or less vertical wind shear to see a tropical cyclone form in favorable conditions. Once we get above that 20 knot mark, things start to get quite unfavorable. And the direction of the shear is shown by the arrows. So what would happen, let's say if we had a tropical cyclone, hypothetically, we're not expecting this. Let's say we had a tropical cyclone off the coast of Gympie. What we would see is that it would try to develop in here. And what would happen is as soon as it tried to develop some strong storms, they'd be pushed away to the southeast really quickly, and the storm would struggle to develop into anything stronger. And in fact, it would weaken out very quickly as well. So this is why wind shear is so important. And as I say, for a tropical cyclone, 700. So when you're looking at your model types, you want to be doing the 700, the 500, and the 300. They're the three levels of the atmosphere you want to be watching. You don't really want to be paying too much attention to what's happening at the surface or the 850. When it's still a very weak tropical low, like the one is now near Tennant Creek, yes, you want to be paying some attention to what's happening here. But certainly once that system starts to become the dominant system, you start looking more at the mid-levels of the atmosphere. And then if it becomes a tropical cyclone, you start looking at the middle and upper levels of the atmosphere to get a better understanding at where it's going to go. Hope that answers your question. Is there a meteorological reason as to why Townsville seems to get little rain, or are we just unlucky? No meteorological reason. There is actually a topographical reason, though. If we take a look at Google Maps, where's Google Maps? Google Maps. And unfortunately, unless we're gonna blow up a lot of the coastline, and then nothing will ever change for Townsville. All right, so let's take a look at the topography of this area. All right, and all right, so we've got nice big mountain ranges here. Mount Elliott, beautiful little mountain. Mount Stewart, a little smaller mountain. We've got Cape Cleveland, nice little mountains on there. Now, the issue is, well, two issues. So a lot of our winds come in from the southeast. So a lot of our rain actually, or a lot of the potential rain on this coastline comes in from the southeast. Now, if you notice Rolling Stone, this is the bane of everyone in Townsville's existence is Rolling Stone, because on every forecast it says rain north of Rolling Stone. The reason being is that Rolling Stone is about that point where the trajectory or the orientation of the coastline changes. Notice how the coastline in Townsville is from basically northwest to southeast. So all the showers coming in on that southeasterly stream are moving parallel to the coastline, so they don't hit Townsville. They don't, by the way, you're not in your own little dome. Ayres got the same dome. Home Hill's got the same dome. Guffalungra's got the same dome. Bowen is probably about the start of the dome. So just do get some perspective here. Townsville isn't alone in the dome effect. Now this dome extends all the way down to Bowen. Now, the expectation here is when we get a southeasterly flow, everything will move parallel. On the odd occasion that we do get showers that do pop up in this area, just around Ayr, they end up hitting Mount Elliott, and on the back end of Mount Elliott's a very tall mountain, by the way. It's no joke. On the back end of that mountain, we actually see dry air coming off those showers, and so we don't end up seeing the opportunity for more rainfall or more clouds to develop over the top of the city. And so what ends up happening here is the atmosphere dumps its load on the windward side of Mount Elliott. On the back side of Mount Elliott, you get very little. And in fact, you know what the driest place in Townsville is? And it is about a 200 to 300 millimeter gradient, rainfall gradient between Townsville City and the dam. The dam actually receives around about 250 millimeters less rain per year than the city. And let's take a look at why that is. If you look at this mountain range here, look at it, look where it's located. Any rainfall at all coming in from the southeast very rarely makes it over into the dam itself because of the rain shadow effect. So not only do you have the situation where your coastline is orientated poorly when it comes to the onshore flow, you have a situation where you're also located in a rain shadow area, and Cape Cleveland does its best to stop anything coming in from the east-southeast as well. So for Townsville to get rain, you need winds coming in from the northeast or the east-northeast. If you can get, you actually do much better than areas around you in a northeasterly flow. So if the wind comes in through here, and you ever see on your weather center, if you start to see the 850 hectopascal range, and we'll just go to Townsville here and just give you a quick look. And actually, we'll go to the Euro. The Euro might show us this. Okay, so we'll go to wind shear. So what we want to see in Townsville, if we're hoping to get some good rain, is we want to see the lower levels of the atmosphere coming in from the northeast. We want to see them at more than 5 knots, of course. That's going to do bugger all for us. But when we get a little bit of forcing, what we want to see is we want to see these winds starting to come in from the northeast. And at this stage, over the next 7 to 10 days, in fact, there's probably no days where Townsville is expected to see this low level northeasterly. So the closest we get is this little circulation that forms just to the north around about Saturday the 7th of January. And in that, if that forms a little closer to us, that's when we might see this northeasterly coming in. Now, in saying that, of course, that doesn't mean Townsville won't get any rain. It just means Townsville probably won't be getting any extreme heavy rains unless we get that northeasterly flow happening. And we need it at stronger than 5 knots, of course. Otherwise, it's not going to do anything. So I hope that answers your Townsville question. So it's, yeah, there is a topographical reason and a coastal orientation reason why you don't get rain. It's not just you're unlucky, and you're just as unlucky as Ayr is, and they're just as unlucky as Bowen is. So it's just this entire coastline is just as unlucky as each other. Given that the MJO is weak at the moment, what other atmospheric drivers, if any, are producing the current surge? I did talk about the reason we're seeing the current surge, and that's because of the tropical cyclone that was in the Philippines. That has died off. We've got a nice little strong high up there near Japan, and I showed you that on the windy TV diagram. And that's what's causing this surge. There are other little factors like little gravity waves, but I probably won't bore you with those details in this update here to the general public. When is the dry air going from inland Queensland? At this stage, let's take a look. All right, so we've got, we'll just see if the Access G is updated. No, the Access G hasn't updated either. Thanks, Bomb. All right. Let's go to the GFS. I don't like the GFS because it always overestimates the amount of moisture in the atmosphere. All right, and we're going to go all the way to, was this a Queensland question? When is, yeah, inland Queensland. All right, so it's an inland Queensland question. So let's move into Queensland, and we'll just look at Queensland as a whole. All right, no, Queensland isn't a whole, by the way. I just meant as one state. All right, so let's look at the 850 to 500. So basically, we're looking for this blue stuff. We don't like blue stuff, and blue stuff should never be around in Queensland during January, unless we're in the far southern parts of the state. Now you can see there's still elements of this blue stuff. Now blue is very dry air in the low to mid levels of the atmosphere. We don't want dry air in this part of the world this time of the year. And what we've got is fairly dry conditions through inland areas, although it does appear as though a trough system in through the southwestern parts of the state and the combination of that with the monsoon trough will start to bring in some moisture. Now, the culprit at the moment is this upper level low that's making sure that we stay pretty dry through the mid levels of the atmosphere. Once that eventually, hopefully, dies down, we will certainly start to see, and you can see it here, look at the amount of moisture that starts flooding inland parts of Queensland. And the expectation then is we're going to see fairly widespread showers and thunderstorms developing probably from around about Monday next week. They may start on Sunday, but you can still see some fairly dry air still to get rid of on Saturday and Sunday. But once we get into Monday, you can see this moisture really starting to advect into inland areas too. So expecting to see a lot of moisture and a lot of storm activity through the week next week across inland areas. So that's good news. Thanks, Nitso. Fantastic stuff. Thank you. Thanks for the answer. Thank you. Does the BOM rely on the same set of models we use here on OCC? Absolutely. Yep. Every single model that we use here on OCC, the Bureau of Meteorology use. The European model is obviously the Bureau of Meteorology's go-to and always has been and always probably will be. The Euro model is by far, well, I won't say by far anymore, but it is the most accurate computer model in the world. And it has been verified like that for, well, at least 10 years that I know of since I've been following the verification data. Interestingly, the Bureau also use Access R as a very, very big, probability indicator of precipitation, amounts of precipitation, convection, and they use the Access R very much for the first 24 to 48 hours. So the Access R model is certainly a go-to model for the BOM in that first couple of days. They probably don't use it for the day 2 to 3 period, but certainly the 1 to 2 day period. And yeah, a very big use of the Access R and the European model. So they're the two big go-tos for the BOM, and they're the ones I always encourage you to go to on your OCC Weather Centre. So Access R should be your go-to for rainfall in the first 24 hours. Almost always. In fact, I believe that Access R gets more things right over Queensland. I'm not sure about the other states. I suspect it gets more things right over the Northern Territory as well. But Queensland, definitely, I find the Access R is actually more accurate than the European in the very short time frame, in the 0 to 24 hour time frame. After that, the European kicks its butt. So that's definitely a go-to. The other two, Access G and GFS, I'd use them, but I'd use them more as a general guide. If all four of them are showing the same thing, well, then you can pretty well bank it. You can almost put it in the bank and say it's going to happen. But a lot of the time they will disagree. So the Access R and the Euro will probably agree. And the GFS and, the Access R and the Access G and the Euro will agree, and the GFS will come up with its own little solution. And that's what frustrates the hell out of us, because sometimes, occasionally, the GFS gets it right and the other three go off on a tangent. It is occasionally where they get it right, but when they do, we look like dills. And so do a lot of the other places that do what we do as well. So anyway. All right, so thanks for the live link, Nitso, loving it. When do your dailies or futures, etc.? Could you flick down the screen as you work so that I get a feel for the layers overlay you were using to better my weather skills? Yeah, sure, I can do that to show you exactly what I'm looking at. Absolutely. All right. Looking at the charts from your updates earlier, that low coming in caused a bit of wind in Cairns this weekend, about 40 to 45 knots. Ooh. Okay, no. That low shouldn't be causing 40 to 45 knots. I think whoever this subscriber is may have Tropics 2808. Tropics, we certainly won't be getting 40 to 45 knots over Cairns. So, I mean, even at any level of the atmosphere here, I can't imagine Cairns getting 40 to 45 knots at any stage. So let's take a look here. And you're flying model planes. So let's say we'll look at the 950 hectopascals. That's 500 meters up. And let's take a look here at the shear over Cairns. No, not a chance. Not a chance in hell. No, I can't see 45 knots over Cairns at any stage over the next, well, 7 days, unless we get some rogue little tropical low that forms right off the coast of the, and you know, in a monsoon, anything's possible, but certainly nothing is modelled at the moment to suggest 45 knots over Cairns. I'll just have a quick look here at the Euro for you. I'm pretty sure there would be no chance of 45 knots, I wouldn't think. But anyway, let's just make sure of that. I don't want to say no and then be made of a dill when it does actually happen. No, light winds, almost no wind, still almost no wind. So we're going into Sunday, into Monday. We do see the monsoon kick in, certainly. So there are northwesterlies that come through, but I can't see 45 knots being in their tropics. So I think you're safe. I think you're safe to fly your planes without any fear of them moving into Vanuatu. So I think you're all good. So at this stage, look, there are going to be some strong winds, no doubt about it, but they're going to be down around southern and central Queensland, not up here in the north, and certainly not up around Cairns, Townsville area. All right, so hopefully I've cleared that up for you. Okay, all right. Hi, Nitso. Can you please explain in more detail how the MJO index forecast graphs work with the yellow line scales and the relation with the black circle? All right, good question. Great question. All right, so let's look for the MJO dynamical forecast product. Is this it? Yep, that's the one. Perfect. All right. Okay, so this is the forecast that we're looking at, and let's look at my favorite. I'm a bit biased. I do like this model. All right. So this is the ECMWF phase diagram model of the MJO. Now, all the little yellow lines, remember how I said that some models are run many times at every different time frame. So these are all the different individual runs. So on the 29th of December, we had this phase diagram created from 50 different European model runs. So there are 50 yellow lines here. Now, this little black circle presents the circle where the amplitude of the MJO actually makes a difference. So once these little yellow lines cross that circle, they actually start to have an effect on the actual global tropics weather. Okay, so when it's inside this circle, the MJO is basically weak and indiscernible. You can't really make it out. Doesn't have much of an effect. It can be variable. It can move from phase 6 to phase 1 in 2 days because there's nothing really being created. Once it crosses the yellow line, once it crosses the little circle, the inner circle here, it actually becomes a force to be reckoned with. And that's the expectation as we go in towards mid-January. And this is what I mean. The monsoon is probably not going anywhere in a hurry at the moment. So once it's in for a little while. So there's no really strong ridging that's going to push it northwards very quickly. So for at least the next week or possibly 2 weeks, maybe even longer, we're stuck with a monsoon. Yippee, that's great news, by the way. I made that sound to be bad, but it's not. It's a great thing because the more that monsoon sticks around, the more chances we've got of picking up those showers and storms, and inside those showers and storms, really heavy rainfall. That's a really good thing that the monsoon sticks around. Even if it's inactive, it doesn't matter. If it sticks around, we're in that moist environment, we get those showers and storms building all the time. So yes, they're hit and miss, but hey, that's good stuff. All right, so that's what the yellow lines mean. That's what the circle means. The green line is the average of the model. The thick green line is the average of the model for the next 7 days. The thin green line is the average of the model for the 7 days after that. Okay, so this forecast goes out to 14 days. We can also see forecasts that go out to 30 days here on the Euro as well. The Bureau of Meteorology one I don't use because it tends to be a bit of a squiggly mess and you can't make out anything from that sort of diagram there. But the Bureau of Meteorology, the cool thing about this one is it goes out even longer than 30 days. So, if they do eventually get this model to somehow become a bit more consistent, it will be a valuable tool because you'll be able to, look at the longer term projection of the MJO. But right now, this is certainly one I don't use. But you can certainly see that there's always, when it's a weak MJO, it's always a lot of disagreement in the modeling as to where it's going to go. So I always like to use the bias corrected version, so the B version here, on the NCPB. Otherwise, this one tends to be very happy whenever we get a low-level circulation center anywhere. It decides that that's the MJO. When we bias correct it, we get a much better idea at what's happening with the MJO. So the grey area here is 1 standard deviation from that mean, and the other grey area is I think it's 2 standard deviations from the mean. So basically this area here would be the highest confidence level of where that MJO and how strong that MJO is. So I hope that answers your question about the MJO. Looks like it could be very busy over here in WA during January. What makes you guys decide to head over that way for a chase? All right, good question. I like these questions. This one's about what we do. I love talking about what we do. All right, so to go for a chase in WA, we need to see a strong cyclone. So Cat 3, Cat 4, Cat 5. They're the 3 categories that we would chase. We need to see it not hitting the North Kimberley because obviously that is so remote, and to charter a flight to take us to wherever the hell we need to go, whether that's Columbaroo. I don't even know if we can get to Trofton Island, but Columbaroo, those sort of areas, you know, because you can't get there by car, obviously, because that road gets cut off well in advance. So we would need it to be hitting primarily the West Kimberley or the Pilbara region. There's various places you can stay in those areas and between those townships. So and that's really what we're looking for. So strong cyclone. We need to have good agreement that it's going to hit the coast. Now a lot of WA cyclones do this, and this frustrates the hell out of us. See this beautiful tropical cyclone late next week, and the expectation on the Euro is that it's just going to round the Northwest Cape and then come back at the coast here towards well, down around Coral Bay, down around Geraldton. Now these systems, they're nice, but they tend to be a bit wishy-washy and tend to be sheared away by the time they're making landfall. This is probably the most frustrating aspect of WA systems is, yes, they grow to be really strong systems, but such a fine line between whether or not they hit the coast or whether or not they go around this northwest coastal region around Exmouth. That's what frustrates the hell out of us, and that's why we can't often make decisions about these systems. The other thing we look for in a tropical cyclone in WA when deciding to chase is the system between an upper level high and an upper level trough? If it is, about 8 times out of 10, it will intensify far more rapidly than the Bureau of Meteorology or computer models will give it credit for. When there's an upper level high located in here around Central Australia, and when there's an upper level trough located way out here, and a system lies in between them, this big exhaust system develops, and it just helps to really create a just like your vehicle. It helps to create a performance vehicle, and so it makes the cyclone from a Hyundai Getz into a V8 turbocharged crazy machine, lethal weapon. So this is what happens in WA systems when we get an upper level ridge here and an upper level trough here. And what it will end up happening then is the system tends to take a little sharp turn to the south, and as it begins that sharp turn to the south, it goes from being a little Hyundai Getz to a Ford performance vehicle or Holden performance vehicle very, very quickly in the space of about 24 hours. That's one of the key things we look for when we're looking at tropical cyclones in WA and whether or not they're going to bomb. So definitely those. So we need it to hit the Pilbara coast. We need there to be good model agreement that it's going to hit the coast. We're never going to get 100%, but we need at least about a 70% model agreement that it's going to hit the coast. And then preferably within about 5 days, we want to see that even increase more. And it needs to be a 3, 4, or 5, or have the potential to become a 3, 4, or 5 on landfall. There's no point spending $10,000 going over to WA and getting data for a Category 1 or 2 tropical cyclone, because we can do that over in Queensland or we can do that over in the Northern Territory. We want the real stuff when we go to WA, and the WA definitely produces the real stuff in comparison to Queensland and NT. The stuff in Queensland and NT, you get one good strong one every 4 or 5 years or 3 or 4 years. The stuff in NT, you probably get one good strong one every 5 or 6 years, and in WA you get at least one strong one every year on an average year. So you guys definitely produce the goods in WA compared to the other states. That's not to take anything away. Don't start hate mailing me. Not to take anything away from people that went through Yassi and Marsha and all those things. Yes, they happen, but they're not a yearly occurrence in Queensland. They are in WA. Hope that answers your question. Is this still going to be available for us with older, slower brains? Yep. This was on YouTube and it'll be available for everyone. Hey, Nitso, is the topography of the Gladstone area similar to what you described for Townsville? We are in a relatively low area of rainfall as well. I've never really looked at the topography, so let's take a look at that with me. All right, so let's have a look at what Gladstone looks like topographically. So remember, Gladstone, slightly different situation there because the trade winds are obviously strongest as you get further and further in northern Queensland. Once you get down around Gladstone, yes, you need that. You still get trade winds, but they're probably not as strong as they're going to be in northern Queensland. No, looking at the orientation of your coastline, there's certainly not the same. Certainly not that same. Northwest southeast trajectory. Remember, Townsville was basically located from Marmore through to probably the north end of this island here. So this is the orientation of Townsville. Your orientation is much less than that. But I guess the key here is there mountain ranges around Gladstone? And I'm not too familiar with your particular area to know how tall these mountain ranges are around Gladstone. So without looking at a topographical map, I would say that no, you're probably not in the same position as Townsville is, and even though you might be feeling that you are low in rainfall, if we take a look at Gladstone's average rainfall, yeah, 880 millimeters. That is pretty low, actually. Now, looking at that, so let's taking a look at who's this Weather Zone. Weather Zone's got it here, 902.5 millimeters at Gladstone, and let's compare that with. Let's see if we can compare that with Bundy. Have I just or Rocky? So you've got about the same as Rocky there, 812 mils, and down to Bundy. Yeah, so look, there's a small difference, 1,018 compared to 900 odd. But when we're talking about Townsville, folks, we're talking about a city that averages about 1,200 mils or 1,000 to 1,200 mils, and as soon as you go 50 k's north, they're averaging 2,000 to 2,500. So we're talking a really significant difference in rainfall. You guys were probably talking about 100, 150 millimeters of rainfall. So yeah, look, I can't see the similarities there between the two. All right. What is your favourite model? My favourite model has always been the Euro. I cop a lot of rubbish for this. It's my go-to model. I treat it as God. I don't treat it as God when I do the updates, of course. I give you a rounded approach. But in my own personal viewing, I love the Euro. And I don't love the model itself. I love the ensemble. It's what all of the Euros are doing together that makes me very, very interested and very happy. The Euro I love because it's a very high resolution model. It knows how to interact little vortices on the monsoon trough a lot better than a model like GFS. GFS, for instance, will spin up a tropical thunderstorm into a vortex, into a tropical cyclone, all in the space of 12 hours, and then into a Cat 5 within the next 12 hours. Doesn't happen in the real world. The Euro knows that, and it makes sure that it knows that, and that's what I love about it. It's far more reliable when it comes to tropical low and tropical cyclone development because of the way it handles tropical convection. Look, they have tweaked the Euro model in the last year or two, and I don't think those tweaks have been positive for cyclone potential, particularly in the longer term. I'm always very, very careful in following the Euro for anything longer than than the next 5 or 6 days. One of the tweaks they did to the Euro model recently is, and I'll show it to you here. So we'll go back into Australia and we'll just look at just the surface level pressures. All right. So one of the weird things they've done to the euro is to try and better initialize circulations. What they've actually done is they've changed the little algorithms that deal with tropical cyclogenesis. And what ends up happening in the longer term in the euro model now is that the euro quickly intensifies tropical cyclones when it shouldn't necessarily do so, to a level that it shouldn't necessarily do so. And that's one of the key negatives in the latest upgrades, is that once we get past about day 7, a lot of the time we see vortices intensifying very quickly. And surface level pressures dropping very quickly when they shouldn't necessarily be doing so, and there's no real indication environmentally that there should be a bombing effect of tropical cyclones at that time, yet the model is doing that. So that is certainly a negative. So when you're looking at the euro, my advice, look at the next 5 days and then take the next 5 days after that with a grain of salt. Pretty well the advice with every model, but the euro, you know, especially that 7 to 10 day time frame, don't pay any attention to how strong it makes a tropical cyclone in that time frame. If the model ensemble, so if the 50 lots of euros are doing the same thing, then start paying attention to it. All right. Why do thunderstorms that come from the tablelands towards Cairns run out of steam when they hit Cairns? Yeah, great question. And who is this? Who is this? Who is this? Who's this person? CB Tops. All right, CB Tops, great question, easy answer. The easy answer is you don't get steering winds. All right, so, well, you do. That's a lie. But generally, the steering winds up in Cairns, that's not a good example. Let's go to now. All right, so we're going here at the 5, let's just go to the 700 hectopascals, 600. That's a middle ground. So this is what's steering your storms right now, folks, in Cairns. Have a look at it. Beautiful, isn't it? Find out how much that is. 2 knots. So what ends up happening is you get these nice storms that build up on the tablelands, and they really don't move anywhere. They might move to the north as they're developing, or to the northeast as they're developing. They hit this big mountain range right near Cairns, and there's no drive to push them over the mountain range because there's no steering. And at the bottom, at the surface, you get this northeasterly sea breeze or easterly sea breeze that comes in and chops the bottom away from the top. And so what we end up getting is just a system that sort of hits the ranges, stays on the ranges, and all you get is the upper level winds. Now, the really, really high winds, you can see here, when we go to the really high winds, the 300 hectopascal winds, we got a nice winds up through Cairns, don't we? Look, 25 knots, 26 knots. And, you know, we tend to see those winds even into the future. You know, they're always a little bit stronger. So you can see here 27 knots. Even when they're really weak, they're still 8 knots, 9 knots. Okay, so they're much stronger than the winds in that are actually steering the system. So you get the light rain from the storms, from the tops of the storms that come over the ranges, but the meaty part of the storm, the convective part of the storm, remains inland. On the coast also, you tend to have a fairly strong fairly strong temperature inversion, which limits any more potential uplift from happening along the coastline. So basically, whatever the storm's got, that's all it's going to get. It's not going to get too much more energy or too much more input from what's going on the coastline as well. The coastline tends to be a lot more stable than the inland areas because all of the convecting, the heating is all happening in the higher ground and the inland areas. The coast doesn't get much heating because the sea breeze keeps the coast nice and cool. So, a combination of factors, and the same goes for Townsville. Yes, I know, same goes for Townsville. Same goes for any northeast Queensland region. They get exactly the same treatment, so it doesn't just happen to Cairns. Fascinated by storms in Darwin. They seem to follow a very narrow band. Oh, that I don't know. I'm sorry. Who's this? Seaflower. Sorry, Seaflower. I've got nothing for you there. I've never really studied storms in Darwin. I'll tell you who does. Great little page, and I'll tell you, this bloke knows everything about storms in Darwin. Get into him about that sort of stuff. If you'll find him on Facebook, I'll just find it here. Let me find out who I'm looking for. Stormscapes Darwin. Oh, I keep forgetting the actual name on Facebook. All right, so this is your page, folks. Stormscapesdarwin.net. Mike is an absolute genius when it comes to tropical thunderstorms, and particularly Darwin thunderstorms. Absolutely amazing, this bloke. So if you've got questions about storms in Darwin and around Darwin, this is the man to see. This is the man to talk to. So make sure you do. I'm not giving him a plug because he's a mate. I'm giving him a plug because he knows what he's on about. And I'm not even going to try and talk to you about Darwin storms. That's the bloke you need to talk to. Hi, Nitze. Give me your outlook for the Daly River region over the next 3 to 4 days. Well, I've pretty much done that. And I've shown you the accumulated totals. So go back through the earlier part of this broadcast and you'll see that. When you do go for a chase, what do you do with the data you collate? So the data we collate, we make available to the Bureau of Meteorology. If they want it, it's up to them. We certainly give them a call and say, here's the information. We also give it to engineering firms who are very interested in it. We also give it to councils. Local councils are very interested in it, who then pass it on to engineers about the data that they got. And what they try to do is match that data up with what they saw on the ground. So in the interest of the Yeppoon, when we went to Chase Marsha, we gave that data out, and that was passed on to engineering firms and construction firms, so they knew the sort of data that they were looking at and matched it up with the sort of damage they were looking at. We also have a very good relationship with JCU, and we always share data with JCU as soon as we go out. So JCU, by the way, is James Cook University. They have a cyclone testing station, and we tend to share all of our information with them as well, and they share their information with us. We use very similar type of equipment, although they use much heavier duty equipment, and so they're less mobile than us. So we can go chase in WA. They can't really do that. Their equipment weighs an absolute ton. But you know, if our equipment went up to a Cat 5 and their equipment went up to a Cat 5, my money's on theirs surviving, and ours might take a tumble. So that's what we do with the data. Obviously, we make it available to our subscribers both at live and then straight after the chase. We make the summary data all available at 10-minute intervals. For our subscribers, we're going to offer data at every minute this year. So in the past, we've offered it every 10 minutes. Nah, not good enough. We're going to try every minute this year, because we think that up to the minute data is vital, and I do mean up to the minute data. And that's definitely one of the upgrades for our subscribers we're doing this year, is you're going to get minute by minute data. What's the difference between infrared 2K, visible 500, infrared rainbow 2K? Nothing seems to change. Oh, that's unusual. All right. Okay, so let me go through this for you. So this question is 719. So, all right. So we've got here infrared. Now, nothing's going to change if you don't click satellite overlay on your weather center. So click satellite overlay, bang, something changes, doesn't it? All right, so this is our infrared 2-kilometer imagery. I only use this overnight. I don't find it that valuable. Anything that this can show me, the higher resolution stuff can show me as well. So then we've got visible 2K. Once again, this is the stuff you can get from the BOM anyway. So this we've just added it because we've got it. But I recommend you don't use this one either. I recommend you use the 500 meter visible. This is 4 times that resolution, and you can just see when we use the 500 how much crisper it's going to be. So let's have a look actually, and look at Darwin, and I'll just show you Darwin difference here between the 2K and the 500 meter imagery, just so you're aware that there is a damn difference. It's a big difference between the stuff that you're getting at 2Ks. So this is 2K data coming at you now. All right, so you can see there a little bit of convection. You can't really, it's a bit patchy. You can't really make out the individual features. Once we go to 500 meter imagery, everything gets a little sharper, and that starts to increase as we go to 128. So let's take a look. There's no good storms happening in Darwin to show you, actually. But anyway, let's look at the visible 2K here. So this is visible 2K. This is what you get from the BOM. Okay, so this is really patched, really pixelated, looks a bit yuck. Okay, so this is visible 500 meters. Notice how it's less pixelated, much sharper resolution. You can tell individual little rain or individual little convective cells inside a generalized stratus layer. So this is really useful. We can tell when there's overshooting tops in thunderstorms. It's really, really awesome stuff. So that's the visible 500. Now remember, nothing happens unless you click satellite overlay. If this is unclicked, then of course you're going to see no difference. All right, visible infrared 1K. So this is a 1K version of that. So it's not going to be as sharp. So you can see that's 500 meters. That's 1K. The good thing about this one is it's actually true. It's got the true color imagery. So so here you go. You've got the color imagery in behind you, whereas you don't get that with the 500 meter imagery. The 500 is sharper, but you don't get the true color. The background color that you've got for blue and brown for the land, or green for the land. So that's the difference there. Now at night time, this will divert to being infrared as well, and that's the cool thing. See, with visible, it just goes to black once we get into nighttime, and you can just see there it is there. As the sun goes down, no more color, therefore can't use it. Whereas the good thing with the infrared is that we can use it overnight. So there you go. Even though we have to move from visible to infrared, we can still use it overnight, which is fantastic. All right, so that's the difference. Oh, infrared rainbow. This shows us the cloud top temperatures. So obviously the darker the colors, the higher the cloud, or the deeper the cloud. So when we're looking at convection, let's get rid of models because that's confusing everything. When we're looking at convection, we're looking for these deep dark colors for the strongest type of thunderstorms. So that's the infrared rainbow 2K. Infrared 2K. So this is once again true color imagery, and once again it offers a change from visible to infrared. Great to look at Australia-wide images, but once we get into local images, so let's say I want to have a look at. There's not too many places still with visible, but let's say I want to have a look at Catherine, for instance, and let's go to Catherine and have a look at the difference there. All right, so that's visible 2K imagery. It's yuck, isn't it? It looks terrible. When you look at the 500 meter imagery, look how much sharper that is. Okay, so this is why I like to use 500. As soon as we get past national level, let's use 500. It's always going to show you more stuff than the IR2K. Water vapor. Water vapor is a 2K res model, 2K res satellite imagery, and water vapor shows us how much water or how much moisture there is in the atmosphere in the middle and upper levels of the atmosphere. So you can see heaps of dry air right through WA, no stuff happening there. Heaps of moisture across the Northern Territory. And you can see this dry patch of air coming through Queensland as well in the middle and upper levels of the atmosphere. So this is what we use the water vapor imagery for. So when it comes to tropical cyclones, we don't want a tropical cyclone that forms on the edge of a moist and dry area. So a tropical cyclone that's trying to form in here has got Buckleys, because what it's going to do is it's going to entrain a dry air around it. So we want tropical cyclones forming in these nice little juicy patches here where there's no dry air around them to really hamper their development or be ingested into the circulation. So very, very important satellite imagery when we're looking at sustained convection and a tropical cyclogenesis, and this one here. So that's what we use it for. It's also really good to look at things like upper level lows, which get lost in satellite imagery. All right, good question. Okay, what's the difference? Yep. Hey, Nitso, a bit of feedback on the presentation. Screen display is a little bit too blurry. Ooh, okay, that's a good point. I'll have to check out the YouTube clip once it's done. It may be a situation where you can control how blurry it is by what you are by your own settings. So maybe if you can click on high definition, or I don't know how YouTube works, but I'm assuming that there's an option there to maybe change the resolution when you're watching it, Doug. So just try that, and maybe that might help. But yeah, I'll have a look at that, and if it is too poor the resolution, we might change and do it some other way. What type of equipment do you use on the chase? Oh wow, where do we start? All right, so we use a weather station, professional grade scientific station. It weighs about 65 kilos. That's our baby. That's our most prized possession. Costs a lot of money. Campbell Scientific Australia have generously donated that. That's why they're our major sponsors, and will probably be for quite a while. And it records all the weather parameters. We also have little stations, little other stations. So in those stations, we do have, just basic parameters, but really the only wind readings that we take is from our actual station. So our station goes 3 meters up into the air, so it takes wind readings at 3 meters above the surface. We then collate those wind readings. We showed images of the surrounding terrain, and we transfer or convert them to 10-meter data. So we've got raw 3-meter data converted to 10-meter data, depending on the topography, terrain, and the frictional coefficient. I'm boring you here with all the science nerdy stuff, but we can transfer the amount of wind that we're getting through a 3 meters to make it a WMO standard 10 meters through a fairly complex little formula. But basically, that's our #1 tool. Obviously, we take videos. So we take everyone that goes on the chase has video recorders, recording equipment. Obviously, for you guys as subscribers, what we do take is what I take is a phone on a helmet, and a phone on the helmet will live stream directly to you. It'll be a special subscriber only live stream, of course, and you'll be going out. So I take a 10-minute wind reading and a 10-minute thermo hydro reading as I go out, and a pressure reading every 10 minutes during a cyclone. So every time I go out into the cyclone to take that reading, you'll come out with me with my little phone head helmet thing on. So you'll be able to see exactly what I see. You'll be able to almost feel what I feel when I go out there and take those readings. It's pretty gnarly stuff. Obviously, when we have a Queensland chase, we always take generators. So we always take a generator, at least 3 to 4 jerry cans. They're always going with us. We take a number of different power inverters. The last thing you want to do is be in a place, particularly in some of these outback places in WA and to a certain extent Queensland. Sometimes power takes a week to come back, sometimes longer, and so we need to be able to be self-sufficient for a week, and not burden whoever we're staying with or wherever we're staying during that week. We need to be self-sufficient, so we take whatever it takes to be self-sufficient for up to a week is what we take with us. Obviously, things like crazy stuff, Dave, like winch, ropes and things like if we need to tie me up as I go out to take a wind reading, because obviously once you fall over, the wind will do the rest. So the whole idea is I need to be securely fastened if I do go out in the middle of a cyclone to take a wind reading. So we'll obviously use a lot of anchors and ropes and things and pulleys and make sure that I am attached to something solid if I do go out. And we've always got people watching for debris and that sort of thing. Obviously walkie-talkies, things like that, that we talk into and help keep each other in the loop about what's going on. It is quite dangerous when we go out there, and it is certainly not a one-man job. If anyone tries to chase a cyclone on their own, with the exception of our mate Josh Morgan, who is a seasoned chaser, I think you're kidding yourself if you're going to try and do it safely. It's really too difficult to do. All right, thanks for the question, mate. Hi, yes, go into settings. All right, so that's all of our subscriber questions for today. Thanks, folks. We've had a fair few. Hope you've enjoyed the update. And as I said, once we finish with the subscriber questions, that's all. We'll finish off the broadcast. Anyway, I'll get some feedback off you over the next couple of days, and you tell me whether you found this interesting, whether you found it a waste of time, and you just rather me do the video updates. You let me know, and then we'll go from there. Thanks for watching. We'll talk again in your state updates. Remember to access your state updates, by the way, you go into the blog. You guys have a secret blog that is not available to the general public. So once you've logged in, you go down here and your 3 video updates for the day are always up there around about 9 o'clock in the morning. And feel free to write a comment down there if you want some clarification on anything that you might have seen on any of those video updates. Don't forget the Future Aussie Cyclone update. That gets updated on Tuesdays and Fridays. But from Sunday, we're going to be updating that because it looks as though if that NT low starts to drift to the northwest, we'll start to get a tropical cyclone threat from that. So your next Future Aussie Cyclone update issued on Sunday morning, January the 1st. and your next month ahead update issued on January 3. So every Tuesday, Friday, we go through the next month of weather across Australia's north. And we also look at where all the different cyclone signals are into the next month. So you can see here where I'm showing some cyclone signals possibly moving towards, and where we're seeing drier and wetter than normal conditions over the next month. So anyway, folks, that's where everything is. So if you are struggling to find anything, pop me an email, or send me a message online, and I'll have a look for you and see if I can help you out, help you find where all the information is. Thanks for watching. Have a great night. We'll talk again soon.